Alright guys, this is going to be a really quick study guide video. I do apologize that it's coming out a little bit later tonight than I expected. We just had to get some things settled so that we can go to the hospital in the morning for the baby to be born. Okay, so these first couple, we're just solving and graphing the following inequalities. So here for the first one, just distribute. So 7n, okay, plus, well, I don't have my calculator. Let me get that out real quick. 7 times 14. It's going to be 98 minus 5 is less than 12n plus 53. Cool. All right. Now let's go ahead and combine like terms. Okay, so there's that. So we'll get 7n plus 93 is less than 12n plus 53. Now at this point, remember, the important thing to do is always get the variable to the left side, meaning let's get rid of the right variable. So subtract 12n on both sides. We should get negative 5n plus 93 is less than 53. Okay, from here, okay, hopefully these steps will be familiar to us. Let's subtract 93 on both sides. We should get negative 5n is less than negative 40. All right, so then lastly, let's just divide by negative 5. And the big thing to remember, if you don't remember this, we're going to get all our problems wrong. When you divide by a negative, you got to flip your sign. So n is greater than, so that's going to be positive 8. Okay, so n is greater than 8. Now this number line is not numbered, so I'm just going to kind of put an 8 right here. And then to graph greater than, well, first of all, it's not also equal to, so we're going to do an open circle. Then we're going to go to the right. And that's all you have to do to graph that. All right, next one. Now this one's a little bit easier, dealing with some smaller values here. Always distribute, so we get negative 6x. Okay, now this needs to be plus. Okay, plus 24 is greater than or equal to 12. Okay, remember it's plus because you're multiplying two negatives together. Okay, now easy question here. Okay, we'll just subtract 24 on both sides. We'll get negative 6x is greater than or equal to negative 12. Now again, same deal as last time. Let's divide by negative 6. And we're going to get x, instead of greater than, now is less than or equal to positive 2. Okay, there's our solution. Now I'm just going to choose to put my 2 like right here. It really doesn't matter, but that's where I'm going to put it. Okay, so circle, we have to close it in because it is also equal to. Then we will go to the left. Cool. All right. Now this one, we can't do anything to the left side, so 3w minus 5, we'll just bring that down, is greater than, well, what's that going to be? Now that's going to be 3w also, right? Because we got to combine our terms. Okay, minus 7. Now, think back to what we did in class. If your variables match, what I suggest doing is just marking them out. Okay, mark them out and just bring down whatever you have left. So negative 5 is greater than negative 7. Well, is that a true statement? Yeah, it's a true statement. So when it's a true statement, what we say is we have infinite solutions, okay? So there's infinite solutions for that. So technically you could graph this by literally filling in the entire number line, because what you're saying is every solution is viable. So just remember with this one, if you're left with a true statement, so negative 5 is greater than negative 7, that's infinite solutions. Okay, then moving over here, let's distribute. We'll get 6y minus 30 is less than, combine these, we'll get 6y again plus 5. So again, mark out your variables. Negative 30 is less than 5. Okay, well, is that a true statement? Well, yeah, so that's definitely a true statement. So again, we have infinite solutions here. Now remember, let's go ahead, let me give you an example of no solutions. Let's say you have 2x plus 6 is greater than 2x plus 8. Okay, if you were to mark out your variables and just bring down 6 is greater than 8, if that is an incorrect statement, that means you have no solution. Okay, you would have no solution in this instance. So I meant to put an example of that on the study guide. I guess I accidentally put 2 infinite solution examples. But remember, this is no solution right here if you're left with a false statement. All right, so moving on. Solve and graph this inequality. Let's go ahead and do that. So again, you can't do anything on the left side, so just 28 minus 7x is less than or equal to. That's going to give us 28x minus 28. All right. Let's actually make that a plus. So positives on the right side now. So this, initially, I know some students might look at this and think there's no solution here, but there is a solution because the variables match. Now what I would do is I would go ahead, even though 28x is the bigger variable, let's get rid of that one because we want the variable to come to the left side. Okay, so we'll get 28 minus, that's going to be minus 35x is less than or equal to 28. Okay, from here we'll subtract out 28 and we will get negative 35x is less than or equal to 0 because 28 minus 28 is 0. Now lastly, just divide by negative 35. And if you divide by a negative, remember your sign, you got to flip it. So x is greater than or equal to, that's just going to be 0. Because 0 divided by anything is going to be 0. Okay, so let's graph it, I guess. We're just going to put one right here, put 0. And now, greater than or equal to, you got to fill it in, and greater than direction would be that way. All right, so going to the next page. All right, so here's a good word problem. This says Mr. Simons charges a flat rate of $20 for a tutoring session, as well as $25 per hour. Okay, Mr. Miller does not, or sorry, Ms. Shepard does not charge a flat rate, but charges $30 per hour. I think the name might be different on this than yours. I think yours says Mr. Miller. This is the other copy that has Ms. Shepard's name. All right, so, but we're going to do the same thing still. This says write an inequality that represents the cost of my tutoring sessions being cheaper than the cost of Ms. Shepard's. So here's how we're going to do that. I, first of all, charge a flat rate of $20. Now, a flat rate only happens one time, so we're not going to put a variable with that. Plus, I charge $25 per hour. So we will put the variable with that, do H for hour. Now, we want to know when my cost is going to be cheaper, otherwise known as less than Ms. Shepard's cost, and hers is $30 per hour. Okay, so this is an easy one to solve. Now, I know I say get the variable to the left side, but with this one, since there's already a variable over here and that's the only thing, let's just go ahead and subtract 25h this time. Okay, minus 25h. Let's take the variable to the right side. That's okay to do once in a while. So we get 20 is less than 5h. Now let's just divide by 5, and we will get h. Well, I'll go ahead and write it this way first. So 4 is less than h. So here's the thing. While that is our answer, we always do want our answer to have the variable on the left side in the end. So flip that around and put h is greater than 4. Make sure it opens up towards the h both times. Now, what does this mean? Well, so what this says is how many hours will it take for my tutoring session to be cheaper? Well, if the h stands for hours, it means we have to have more than 4 hours of tutoring. So the first set amount of hours it's going to take for my tutoring to be cheaper is going to be 5 hours. Okay, that essentially is the answer right there. It's going to take 5 hours. All right, so let's distribute here. We'll get 6 over 7x minus 6 is greater than 5 plus 6 over 7x. Oh, snap. Okay, so what's going on here? Well, again, let's mark our variables out. We get negative 6 is greater than 5. Is that a true statement? So no, that's not a true statement. So this means there's no solutions, right? Okay, so I guess I did put an example of that on here. I thought I didn't earlier. So there's no solution there. Negative 6 is definitely not greater than positive 5. All right, here, remember the trick. This is really just a negative 1. Okay, so let's distribute that out. We will get negative 1x or just negative x, okay, plus 5. And that is going to be less than 6x plus 6 times 1 is 6 minus 7x. Now it looks like we have some terms to combine here. So negative x plus 5 is less than, well, 6 minus 7 will be negative 1. So we will get negative 1x again, or just negative x, okay, plus 6. All right, so again, our variables match. Okay, we're getting lots of examples of these, so mark them out. We get 5 is less than 6. And so that is a true statement, meaning we have an infinite number of solutions. All right, so now these are compound inequalities. So if you remember compound inequalities, we have and, and we have or compound inequalities. So we're going to solve these, then we're going to kind of make a makeshift graph for them. All right, so this first one, this is an and. Okay, always remember when it's written like this, it is an and compound inequality. If you do not see the word or, it is not an or. Okay, so with this one, think of it as having 3 sides to it. Okay, we have the first side, second side, third side. Now let's go ahead and solve it for our variable right here. So think of it as this is the side we're trying to work from. We want to get this x by itself. So we want to get rid of this plus 2 and get rid of this times 2. So if this were an equation, what would we do first? Well, we would subtract 2, right? Okay, so negative 6 minus 2 is going to be negative 8. That is less than, well, all we have left here is 2x, which is less than or equal to 18. Don't forget the or equal to part. It's very important. So then lastly, we would just divide by 2, right? Still trying to get x by itself, so divide out our 2. Negative 8 divided by 2 is going to be negative 4. Okay, and then we have x, so negative 4 is less than x, which is less than or equal to 9. Okay, and so that is our solution. Let's throw that on a number line real quick. All right, so our lower bound is negative 4. Our upper bound is 9. Okay, we're going to put our points there. Now, negative 4 is going to stay open, and positive 9 is going to be filled in because of the equal to. And now remember what an and inequality looks like. They just connect right there in the middle, okay? They do not extend past their connection because the solution has to work for both inequalities, or for the whole thing, and so it does not extend past either. They just connect in the middle, and they're good, okay? So this is an or, okay? This is an or inequality because of the word or, and now treat it as if they're 2 separate inequalities. We have this one on the left and this one on the right. So first I'll distribute 3x minus 3 is less than 9. Now typically these with the or inequalities are going to be very easy to solve. They don't tend to be many steps to find the solution. So I'll solve this one on the left first. Okay, hopefully we don't really need my help with this one, but of course I'm going to do it since this is the video for the study guide. These steps should be pretty straightforward. Okay, divide. And now do not flip the sign with this one. Keep it the same because we divided by a positive number here. Okay, so x is less than 4 is our first solution. And now let's just add 5. So negative 2x. Now don't forget to bring that negative down every time. Negative 2x is greater than 20. Now we divide out our negative 2. Now remember here we do flip the sign. Okay, if you divide by a negative, you got to flip that sign. So x is less than negative 10. So if you notice, both of these are going to be going the same direction, but for an or inequality, that is okay. Okay, we can have that. That's not necessarily a bad thing. So we have our lower value of negative 10 down here, our upper value of 4 over here. Okay, now neither of these are going to be filled in circles because neither of them are also equal to. They're both less than, however. So less than goes to the left. So negative 10 is less than negative 10, and 4. So we have less than 4 also. So you notice that even though this inequality runs into this inequality, it continues to go. That is, again, because it is an or inequality. Okay, or inequalities don't stop just because they come in contact with each other. All right, let's go to the last. All right, so what compound inequality describes this graph? Well, first thing to note is that this is an and inequality. Remember, if it looks like this, if it stops when they run into each other, this is an and inequality. So just knowing that, we can already mark out 2 different answers. Okay, so even if we have to end up guessing on this, whether it's this or this, at least we've marked out half of our choices, and now it's a 50-50 shot at getting it right. So we have negative 3 as our lesser value and 0 as our upper value, and both of these have those. So we're going to have to look at the dots. Okay, negative 3 is filled in. Okay, meaning it has to have the equal to sign. 0 is not filled in, so there's no equal to sign. Well, let's look over here. This one has the equal to part with negative 3, and this does not with the 0. That matches. This one is incorrect because this shows that it should be an open circle here, which it is not. So here is our solution. Negative 3 is less than or equal to x, which is less than 0. All right, so this one's not multiple choice. We have to build it. Now this, remember, this is not an and, this is an or compound inequality. These are very easy to write because let's just look at this one first and write that. So starting at 5, we're going in the less than direction. So we'll just say x is less than 5. So simple enough, right? And then we put or. So x is less than 5, or x is, well, we're starting here at 7. X is what then 7? Well, x is going to be greater than 7. And that is already our solution. Okay, it's already our inequality right there. Okay, and then the final question here. This is the one that we did in class. There will be a question like this on the test. Remember, how do you find the area of a rectangle? Well, it is length times width, right? So area of a rectangle is just length times width. So let's go ahead and get that real quick. So the area is 3x times 7x, which is going to be 21x. Okay, so there's that. Now, let's go up to the question. The area of a rectangle is defined as 63 is less than or equal to the area, which is less than or equal to 168. Now, don't let this confuse you. All this is saying is that the area of this rectangle is between these two values. So let's write an inequality for that. 63 is our lower value. And now, what do we just say our area is going to be defined as? Well, it's going to be 21x. And now that's less than or equal to 168. So we've already answered the first part. It said write a compound inequality for the area in terms of x. And what this inequality says is that the area of this rectangle, while we don't know exactly what it is, we do know it has to be between the values of 63 and 168. Or it could be equal to one of them. Now, part B to this question says, what is the solution? Well, the solution is simply, when we solve it, when we get x by itself. So what do we need to do to get x by itself? Well, with this and inequality, let's just divide everything by 21, right? Because x is right here in the middle, and we need to get it by itself. So when we divide by 21, that's going to accomplish that. So 63 divided by 21 is going to be 3. So 3 is less than or equal to x, which is less than or equal to 8. So what this solution tells us is that while we don't exactly know what x equals, okay, we don't know the exact value of it, we do know that x has to be between the numbers of 3 and 8. And just for good measure, let's go ahead and graph that with a makeshift number line. We have 3, we have 8. This is an and inequality. We're going to fill them both in because they have the equal to part, and they're going to connect in the middle. All right, with that being said, if you do this study guide and you bring it back, your substitute teacher, Mr. Holmes, is going to let you use it on the test. Please do the study guide. All right, good luck on the test. Y'all do your best. I know you can, and y'all have a great week.